Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part 2 video, I would like to explain about what is the mirror formula, how we can derive the mirror formula with the help of a suitable diagram from the chapter of reflection of light at spherical or curved surfaces. Already in our previous video in the same chapter, I clearly explained to you about what is the relation between radius of curvature and focal length of a mirror or lenses for the spherical surfaces. Then finally, I proved that R is equals to 2f and f is equals to r upon 2, that is 1. Means radius of curvature is always twice than the focal length. So means focal length is 10 centimeter for any given radius of for any given spherical surface. Then automatically radius of curvature is 2 into 10, then 20 centimeter. That is the meaning of that. Now let me come to that one, our topic. Simply we are called mirror formula. One upon f is equals to 1 upon v plus 1 upon u, or 1 upon f is equals to 1 upon u plus 1 upon v. This is called mirror formula. So f is the focal length, v is the image distance, u is the objective distance. Now I will be derive this formula with the help of a suitable diagram. So here we are observing that it is a spherical surface. The surface of that one, it is appears like which one? It is a concave. Why? Because of I says that the reflecting surface is inward. The reflecting surface is inward. That mirror we are called concave mirror. Now here for the concave mirror this is the principal axis. It is the pole of the mirror, principal focus, center of curvature. Now here we are observing that. So now we can take a point, the object. Object is placed in front of the concave mirror beyond the center of curvature. Listen very carefully. So one object you have taken, that object is placed on the principal axis, okay, beyond the center of curvature for the concave mirror. Now here, so from this one you are considered that two rays are, we are considered that one ray is, okay, fall onto the curved surface at point A by making certain angle with the which one principal axis, that is the alpha. That's why here, and the second ray will be passing along the principal axis and fall at point P, then it return to the back. That is, you know very clearly. Listen very carefully. O is the position of the object. From the object we are considered the two rays. Where the object is there here, beyond the center of curvature. That's why from this object we can set the two rays. One ray will be fall on the spherical surface at point A. So it is obliquely fall on that one with respect to which one? Okay, means this incident ray will be fall at point A on the spherical surface by making the alpha angle with the principal axis. Then after the reflection, we know that if incident ray parallel to the principal axis, after the reflection it is passing through the principal focus. But here, so this incident ray is not parallel to the principal axis. That's why what will be happen here? So after this one, you know that you draw a tangential line. If you can draw the tangential, with help of the tangential one, we draw a normal. This is exactly with which one point you see. So this is the incident ray, it is the normal. The angle between incident ray and the normal is called angle of incidence. Next, so we know that when it will be fall, it will be reflected. The reflected ray is passing through like this one. It is not exactly F. That is, you know very clearly. That's why this is the reflected ray. It is the normal. The angle between reflected ray and the normal is called angle of reflection. But angle I, we consider the theta. Angle R, we consider the theta. Because of, okay, the curved mirrors, means our spherical mirrors is also follow the laws of reflection. That's why angle I is equals to angle R. That is the meaning of that one. So that what we know that here, so this is the theta, means it is also theta. Both are having the same angle. Now here we are observing that, okay, alpha is the angle made by this one with respect to which one? Principal axis. Beta is the angle between the, okay, normal and principal axis, and gamma is the angle between reflected ray passing through the principal axis and the principal axis. Now the distance from pole of the mirror to object or position of the object. The distance from pole of the mirror to position of the object is called object distance. Next, the distance from pole of the mirror to image. Here image will be found. Is correct or not? You can easily find out. How means this is the first reflected ray. So the second ray will be fall at point P. We know that it return to back or retrace back. That's why the first reflected ray, second reflected ray, both are meet at this point. That's why at this point, what will be found? Image will be found. So that the distance from pole of the mirror to image position is called image distance. Next, the distance from pole of the mirror to, okay, principal focus is called focal length. The distance from pole of the mirror to center of curvature is called R. So that is the primary idea about the diagram. Now from the point to A is called point of incident. From the point of incident we draw a, okay, perpendicular line onto the principal axis. Where it meets the principal axis, that is we can say as M. Okay. Now this is the primary idea. Now let me come to that one. Here you are observing that A, O, M. So means okay, A to O, M. It is appears like a which one? Right angle triangle. Like the same way. A, C, M. It is also a right angle triangle. Next, A, I, M. It is also a right angle triangle. That's why. So now, first of all, from the figure, so triangle AOM. Okay, we can write that tan alpha. Okay, AOM. In this right angle triangle, tan alpha, already I said in the previous video also, tan theta is nothing but opposite side by adjacent side. That's why AM upon MO. Like the same next triangle means right angle triangle ACM, tan beta equals to AM upon MC. Like the same way next right angle triangle AIM. So tan gamma AM upon MI. So that's why like that one, tan alpha is equals to AM upon MO. Next, it is like this one. Next, from triangle ACM, tan beta is equals to AM upon MC. Next, triangle AIM. So tan gamma is equals to AM upon MI. So these are the values. Next, like the same way, one more thing is also. Okay. AOC. Next, ACI. Here listen very carefully. AOC. It is appear like a triangular shape. In this one, alpha, theta are the interior angles and beta is the exterior angle. We know that. So AOC is appears like a triangular shape. In this one, alpha and theta are interior angles and beta is the exterior angle. Like the same way. Next, from ACI, it is also triangular shape is there. In this one, beta and theta are the interior angles, gamma is the exterior angle. We know that according to the mathematics, okay, the sum of two interior angles is equal to the exterior angle. That's right. So by using that, okay, way we can write out that. From triangular AOC, beta is equals to the exterior angle is equals to sum of the two interior angles, alpha plus theta. From this one, theta is equals to, okay, then theta is equals to alpha transfer to this side, beta minus alpha. So theta is there here, alpha is transferred to this side, beta minus alpha. So means theta is nothing but here, which value? I value, angle of incident. Next, like the same way, from triangle, okay, ACI. So gamma is the exterior angle and beta plus theta are the interior angles. Already theta value is there here. What is the one? Beta minus gamma, sorry, alpha. That's why this value is substituted here. Then gamma is equals to beta plus beta minus alpha. Beta plus beta, 2 beta. Then gamma is equals to 2 beta minus alpha. But so minus alpha transferred to this side, it becomes to the plus. That's right. So 2 beta is equals to gamma plus alpha. This one is there. Okay. If theta is very small, tan theta is approximately theta. So why we can consider like that one, I explained in our previous video. If theta is very small, for example, okay, tan 0.1 value is nearly equals to the 0.10012 like that one. So means here you are understanding very clearly what is the tan theta value that is approximately equal to the theta. So that's why if theta is very small, tan theta is approximately or nearly equals to the theta. That's why based on that situation, tan alpha is equals to alpha, tan beta is equals to beta, tan gamma is equals to gamma, because of alpha, beta, gamma are replaces by which one? Theta, that is one. So tan theta is equals to theta means tan alpha is alpha, tan beta is beta, tan gamma is gamma, that is meaning. And also okay, M is on the P is nothing but coincide. M is on the P is nothing but coincide. So hence we consider AM is equals to AP. So listen. So in the previous videos also I clearly explained that if the angle is very small, here O, okay, like this mode it is which point? A point. It is the angle is small or not? If from this one we draw one perpendicular line, it is exactly, so which one? P. That's why. So M is exactly coincident with which one? P. That's why AM is nothing but what you can write? AP. First, in which cases if the angle is small. If the angle is small means here angle is more. If angle is small means incident ray will be not here. It will be fall very near to the point P. That's why we draw a perpendicular line onto the principal axis. It exactly with the which one? P. That's why M is on the P. That is we can consider. So that's why, okay, what we are considering that, okay, AM is equals to AP and M is in the place of which one? Simply, okay, AM is equals to AP or simply M is on the P. That's why we can write that AM is equals to AP and M is equals to 3 means M is on the P. These two situations we are substituted here. Okay. Now tan alpha is equals to alpha, that is equals to what is that one? AM upon AM means what you can write here? AP directly you can write. So AM means AP upon MO. M means P, that's why PO. Next, tan beta is equals to beta, that is equals to, okay, AM upon MC. AM means AP upon PC. Next, tan gamma is equals to gamma, that is equals to AP upon PI. So in the place of M we can write the P and in the place of AM we can write the AP. Why? Because of means if the angle is small, the incident ray will be fall at point A, but this point A is very near to the point P. That's why when you draw the perpendicular line onto the principal axis, M is exactly coincide with the P. But that way we can cancel like this one. Now we know that what is the formula? 2 beta is equals to gamma plus alpha. It is the equation number 1 where I can say that. That's why alpha, beta, gamma values are substituted in the equation 1. That is 1. Alpha, beta and gamma. Alpha, beta and gamma values are substituted in equation 1. Okay. So when we substitute that all the values in the equation 1, 2 into beta, beta means AP upon PC. That's right, AP upon PC, that is equals to next gamma plus alpha. So AP upon PI. Next alpha, AP upon PO. So here you are observing that in the left hand side and the right hand side AP is there. That's why. So 2 are AP upon PC is equals to AP is the common factor in the right hand side. Then 1 upon PI plus 1 upon PO. AP get cancelled here. So what is the remaining one? 2 of PC. PC means the distance from P to center of curvature means R. That is equals to next 1 upon PI. 1 upon P to I means image B plus 1 upon U. Here we are observing. Next 2 upon R is nothing but radius of curvature. So in our previous video, I clearly explained and proved that R is equals to 2F. That's right. In the place of R, we can write the 2F. That is equals to 1 by V plus 1 by U. 2 get cancelled. What is the remaining one? 1 upon F is equals to 1 upon V plus 1 upon U. Okay, so this is the mirror formula. So what is the mirror formula? 1 upon F is nothing but focal length is equals to 1 upon V is nothing but image distance plus 1 upon U is nothing but object distance. That's why finally, so we prove that or we derive what is the mirror formula. But actually, okay, when you can solve any numericals by using the mirror formula or lenses formula, so you must be used rules for sign conversion. What are the rules for sign conversion? So I will tell you this one, that values, that things we can keep in your mind in a proper way. So once again listen very carefully. It is a, okay, which mirror? Concave mirror. For the concave mirror, I will draw an principal axis. So it is the pole of the mirror. O is the position of the object. From the object, we can set the two rays. One ray will be fall at point A. Another ray will be fall at point P by passing through the principal axis. When the light will be fall at point A, it will be follow the rules of laws of reflection and reflected back and passing through the point I on the principal axis. Then here, so this ray is makes the alpha angle with the principal axis. The normal is makes the beta angle with the principal axis, and the reflected ray is makes the gamma angle with the principal axis. The distance from P to O is called object distance. The distance from P to I means image is called image distance. The distance from P to C is called radius of curvature. The distance from P to F is called focal length. And after that one, this is everyone, we know that very clearly. So we get the formula 1 upon f is equals to 1 upon v plus 1 upon u. This is one is there. Okay. So here we are using the which mirror? Concave mirror. That's why according to rules for sine conversion. So according to the rules for sine conversion, what we can do here? So I said, okay, very clearly in IIT oriented mode for you also. Just once again I will explain. Okay. What are the rules for sine conversion? First one, pole of the mirror we consider as a origin. Listen very carefully. Pole of the mirror we are considered as on origin. Origin means main point. And second thing is all the distances are measured from pole of the mirror. First one is pole of the mirror we consider as on origin, and second one is all the distances measured from the pole of the mirror. Is nothing but you can measure the distance. Okay, object distance. Object distance means the distance from object to pole. Not correct. The distance from pole of the mirror to object. That's why. Okay, next. Image distance. Image distance means the distance from image to pole. Not correct. The distance from pole of the mirror to image. This is the proper way. That's why any distance you must be measured from pole of the mirror only. Next one. Okay. The distances measured in the direction of incident ray were taken as positive. The distance measured in the direction of opposite to the incident ray we can taken as a negative. Height measured above the principal axis taken as a positive. Height measured below the principal axis taken as a negative. So first thing, what is that one? Pole is considered as an origin. All the distance measured from pole of the mirror. Third one, the distances measured in the direction of incident ray taken as a positive. The distances measured opposite to the direction of incident ray taken as a negative. Next one, height measured above the principal axis is positive. Height measured below the principal axis is negative. Like it is just like, once again I will explain that. This one. If the ray will be moving like this mode, it is in a concave mirror like this mode, we can consider that. Anyone? So object is here, the rays will be moving like this. Means the objects are moved from left, the rays will be moved from left to right. That's why if you can, this is the pole, means origin, like move we are consider that. If you can measure the any distance in the direction of incident ray, it is which value? Plus, because of this part is plus x according to the mathematics. If any distance you measured opposite to the incident ray, this is the opposite direction for the incident ray or not. That's why this is we can take it as a negative because of here negative x-axis means values are in negative. Like the same way. This is the principal axis for this one. We can consider that. Okay, the values above the principal axis we can means height is measured above the principal axis taken as positive because of it is in plus y. Height measured below the principal axis. This is which one? Minus y. That's why these values are negative. This is the measure. Okay. Things what follow in the rules for sine conversion. Now let me come to that. According to rules for sine conversion. Okay. So from the diagram, f is equals to u is equals to next v is equals to what will happen? So okay, first f means focal length. The distance from pole of the mirror to focal length is called principal focus is called focal length. That's why every distance it must be measured from pole of the mirror. Here we are observing that O is the object object position. From this one, ray will be moving like this or this one. Mostly means left to right. But here, the distance from pole of the mirror to principal focus is called focal length. That's why our measuring direction is opposite to which one? Incident ray. That's why focal length is negative. Next, the distance from pole of the mirror to position of the object. That's why the measuring direction is from P to O. That's why it is also opposite to the incident ray. Incident ray is moving from left to right, but our measuring is here in this diagram. So from P to opposite to the incident ray. Next, the distance from pole of the mirror to image is called image distance. It is also opposite to the which one? Means our measuring direction is opposite to the incident ray. That's why F is negative, U is negative, and V is also negative. Then these values is substitute here. 1 upon minus F is equals to 1 upon minus U plus 1 upon minus U is equals to 1 by V plus 1 by minus is the common. Minus get. That's why. What is the value? 1 upon F is equals to 1 upon V plus 1 upon U. So this is the mirror formula. That's right. So this is not the mirror formula. After using the rules first, up to here enough. So this is the mirror formula for which one? Concave mirror. For convex mirror, what is the mirror formula? You know that for convex mirror, object is where? In front of the mirror. Focal length, radius of curvature is present where? Behind the mirror. Image is also found behind the mirror. That's why. So this is the mirror formula for all the mirrors. But this is the general mirror formula. But when you can use the convex and the concave mirror, the formula is slightly changes. So, but finally, this is the formula for which one? Mirror formula for concave mirror. But what about the convex? It is the pole of the mirror. It is the object O. This is the U. F, C. Like this. Angle I, angle R. This is the theta, this is the theta. Now here we are observing that here image will be found. That's why the distance from P to O is opposite to the direction of incident ray. Ray will be moving from left to right. But to measure the object distance P to O, it is inside right to left, means opposite to this. Next, the distance from P to F, it is same as left to right, means in the direction of incident ray. P to I, same direction. P to C, same direction, but this one only opposite. That's why U is negative. For which one? Convex mirror. During the examination you can stop up to here only. This is the excess for you. V is positive and F is also positive. 1 upon F is equals to 1 upon V minus 1 upon V. So this is the mirror formula for which one? Convex mirror. Concave mirror is plus, here convex is